All right, now that we've completed the unit circle for all our 30-degree reference angles or pi over 6 reference angles, we can actually use it to solve problems. That's why we are completing the unit circle so that we can solve problems like those in number 8. So let's take a look at what this means, this expression right here, where it says the sine of 150 degrees. That's what we want to take a look at. What do we mean by that? Well, the first thing is we know that the sine of an angle is always the y-coordinate of the point of the unit circle that that angle corresponds to. So what does that mean? Basically, if we're trying to figure out the sine of 150 degrees, we just need to locate 150 degrees on the unit circle. So here is 150 degrees right here. And that's our angle right there. So at that angle, we just need to find the y-coordinate at that angle. Well, the y-coordinate of that point is merely the coordinate right here. So it's 1/2. It's also the opposite side to the reference angle. So that opposite side's length is 1/2 unit long because the hypotenuse was 1 unit long. Okay, so the key is that we want to use the y-coordinate for the angle when we're dealing with sine. Going on to the next problem, the cosine of negative pi over 6 means since we're dealing with cosine, this time we're dealing with the x-coordinate. So the x-coordinate for this angle right here, negative pi over 6, we just need to locate the angle. So negative pi over 6 is coterminal with 11 pi over 6. So this here is negative pi over 6. Since we're looking for the cosine of this angle right here, since we're looking for the cosine of the angle, we just need to use the x-coordinate for that point. And so therefore, our answer is merely the x-coordinate of rad 3 over 2. That's this guy right there. So rad 3 over 2 is our answer for the second problem for B. Another way to check that we're right, and we know it's a positive rad 3 over 2, is because all students take classes. Cosine is positive in the fourth quadrant. That's why we got a positive rad 3 over 2. All right, lastly, we're going to take a look at tangent. Now, the tangent of 7 pi over 6. One thing to review is that tangent is always dealing with the y-coordinate divided by the x-coordinate. It's the opposite side over the adjacent side. And the opposite leg will be the vertical, the y, and the adjacent side will be the horizontal, or the x, always. All right, so for 7 pi over 6, we are dealing with this angle right here. That point corresponds with a terminal ray at 7 pi over 6. So the y-coordinate at that point, this is important, is a negative 1/2. That's this value right here. We got to make sure we use the positive and negative correctly. The x-coordinate is going to be that, negative rad 3 over 2. Okay, so all we need to do is simplify this answer, and then we'll be done. Remember, when we divide a fraction, that's the same as multiplying by the reciprocal of the denominator. So all we need to do is flip the denominator to actually do the calculation. So that becomes 2 over rad 3. And again, that's still negative. Okay? So let's see what happens when we multiply numerators and denominators. Well, one thing that's going to happen is the 2's are going to cancel, and they'll cancel to 1. So on the numerators, when we multiply a -1 times a -1, we're going to get a +1. And +1 times rad 3 is 1 over rad 3. That we need to rationalize. So we'll multiply by rad 3 over rad 3. And our final answer will be 1 times rad 3, which is rad 3. Rad 3 times rad 3 is rad 9, or 3. And this gives us our final answer for the tangent of 7 pi over 6. Thanks for watching.